Putting on the recording. I think recording has started. All right, good day, everyone. Several times you're joining us. My name is Olanwaju Onyiboke. I'm a senior cloud advocate at Microsoft. And today we're going to continue in the 30 days of learning engagement, data analysis, and machine learning track. To be very honest, it's been a very impactful session so far. We've seen people building their first machine learning model, which they've not been able to do before. We've seen people getting familiar with Azure as a cloud because you are not literally building a model and leaving that model in a Jupyter notebook or Visual Studio Code. You're also being taught how to take the model from your machine to the cloud. And that is the topic of deployment. We've touched regular regression classification regression model. We've moved to classification model, which both of them are still supervised machine learning. Today is unique because we are considering another side of machine learning, which is unsupervised, and that is where we have clustering algorithm. And we have the pleasure of hosting one of our own that we're always proud of, always, who has taken this knowledge that she built all over the world. Bumi, we was in Kenya not quite long. Was it Kenya? Bumi?
So it's Rwanda.
You see, because a lot of traveling opportunities to showcase the skill and the solutions she's building. She was actually in Rwanda not quite long to represent students, to showcase her project and lead, a session on those solutions. She's a student. Yes, she's still a student, and she started this journey while still being a student. And this is the goal that as you're starting now, as you're learning with us, you're going to learn from her today. I'm so much happy to introduce Bumi to each and every one of you. She is a Microsoft Learn Student Ambassador and a very active community leader in Nigeria, and her solution is finding its way all over the world. So Bumi, I'm going to hand this over to you to walk us through this and also show us how to build this model. Personally, I'm excited, and I have my second PC here trying to see what I can come up with as well. Over to you, Bumi.
Thank you so much. Thank you so much, everyone. So I'm excited to be doing this session today. Right. I hope that you're going to learn a lot and at least be able to build something out at the end. So I want to confirm, can you see my screen?
I can see your screen, I can see your face, and I can hear you loud and clear.
Okay, that's awesome. That's fine. Okay. So today I'm going to be talking about
Same here
cluster.
also.
Okay, thank you. So today I'm going to talk all about clustering. I'm going to mention some clustering methods and algorithms. We're also going to cluster a sample data, and I'm going to talk about mostly about k-means clustering because that's like the very popular one you would see around. Then I'm also going to talk about silhouette scoring, Helbo method, and variance. And at the end, I'm going to give you guys a simple challenge. So I would like you to also try out other clustering algorithms. Yeah. So I'm going to be assuming that you're familiar with building machine learning models. I'm also going to be familiar that I'm going to be assuming that you're familiar with data visualization tools like matplotlib, Seaborn. But yeah. So let's start. Just in case you have questions, you can type them in the chat. I would be happy to answer them after the session. Okay. So, what is clustering? Clustering is a type of unsupervised learning, and just like a recap, unsupervised learning is when you're training a machine learning algorithm without giving it labels. Like supervised learning, which you've had to work on, had to build a logistic regression model or a linear regression model. You were telling the algorithm that okay, this is a group of features, and then this is the target that I want to predict. But in an unsupervised learning, you don't have a target, right? You're asking the algorithm to actually figure out that target for you, right? And a simple use case is this: probably you have like a database of students, right? Probably across the whole school, and then you're trying to ask the algorithm to group this database of students, kind of find groups in which you can actually group the students for better reachability or accessibility. So you might want to group them based on their age, you want to group them based on their probably particular performance or a particular trend. So you're giving the algorithm to find the best way you can group these students, the best way you can group these students. So this is like an example of unsupervised learning. So the model is going to kind of find patterns in this data and then group them together. Okay, it seems like this data point is similar to this data point, then it assumes they're in the same class. Yeah, so that's the way a clustering, an unsupervised learning algorithm kind of works. So yeah, basically like clustering too. So it sorts through an unlabeled data and then groups them into classes according to patterns it finds in this data. So a couple of clustering methods. The first is k-means. So k-means is very, very popular. It's probably what you would see when you type clustering, right? So what k-means tries to do is that it tries to group probably these data sets, right? Try to make them into groups based on means, right? So you have a centroid, which is like the mean, which is the center point. Then it tries to find data points that are closer to that centroid. So the centroid here is like a center point, which is like the mean. Then it tries to find data points that are closer to that mean, and then it forms clusters based on that. So other algorithms, affinity propagation, you have density-based clustering method, which is the DBSCN, the agglomerative clustering Gaussian mixtures. So this might look like big names, right? But we're going to actually have hands-on with these algorithms and you probably understand them better. Okay. So clustering algorithms, they are quite over 100. There are actually a lot of them. So you have hierarchical clustering, which what it does is that it tries to unlike central clustering, right? What it tries to do is, okay, this is this data point. What data point is closer to it? So it brings them together, then looks for another data point that is closer to it, brings them together to find that data point that is closer to it, brings them together. In that way, it's forming clusters. Also, like grid-based clustering, in the sense that it divides the whole data into grids and then forms cluster based on that. So if you say, okay, I want six grids, so it divides the whole data set into grids, and whatever that data point falls into in that grid. So that's like grid-based clustering. Then you have density-based clustering, and in density, when you say a data is dense, right? What you're trying to do is that you're trying to see how close this probably a particular data point is to the mean. Like you're trying to see, okay, in this cluster, probably in a particular cluster, how close are these data points together? So that is you trying to find them. So between a particular cluster, right? Trying to see, okay, how close are these data points? How close are these data points to themselves? So that's density-based clustering algorithm. So each of these clustering algorithms have their own places that you apply them to. They have their own scenarios where you use them, right? So yeah, let's cluster example data, but okay, let me come back to this data. Okay, so as I explained before, k-means is used to divide and partition data into k clusters, right? So just as you can see, right, you can see a particular data set split into three different groups. And then you can see at the point there is like a black dot. So that black dot is like the centroid, and every other data point around it, right, it chooses it based on the distance between that point and the other data points. So that is how it kind of forms its own classes. So yeah. Okay, let's quickly do something before I talk about silhouette score. Okay, just a sec. Let me try to stop sharing and share something else. Okay, give me like a second. Okay, I'm trying to share my notebook. Okay, please let me know if you can see my screen.
Yes, I can
Okay,
see
awesome.
your screen now.
Okay, okay, that's great. So this is the notebook we're going to be working with, and we're going to be using um a particular data set, which is Nigerian song on Spotify. So the data set is gotten from Nigerian songs from Spotify, and then we're going to actually see how we can use clustering to group this data, right? Find groups we can kind of cluster this into, like probably based on the danceability, based on how it's trending, based on things like that. So briefly, right? I'm sure I'm going to assume that you're familiar with loading data, right? So this is the link to data set. I would drop this after the session so that you can have access to it, right? So yeah, okay. So I'm going to load the data. So you can see it has the name of the song, the album, the artist top okay, load. Okay, the artist top genre, the release date, length, the popularity, danceability, autistic, energy, blah blah blah, and other features. Right. So this is the data set, and you can see all the features. Now we don't have a target, right? Unlike other data sets you've worked with where you are like, okay, maybe you want to predict a particular feature. So now we are not predicting, we're just trying to see how well this algorithm would be able to find groups that best describe this this kind of Nigerian music. Okay. So a very let me try to relate this to real life scenarios. So in the sense that you okay, so a customer walks into a shop, or probably let me say an online store, right? And then this company has a customer database of okay customers that have purchased stuff before, new customers when they bought it, kind of products they bought, and the company is trying to increase its sales, is trying to increase its revenue, and what they want to do is they want to give you what they call that's targeted marketing. So they want to give each customer what the customer would like. But how would they know what the customer would like, right? So how would they know? Okay, imagine they're having like tens of thousands of customers, right? Will they start going to each everyone? Okay, the person buys this product. Okay, buys shoes, this type of shoe, and then he has bought that shoe like 3 times, probably the same brand, maybe different styles. Like it's like literally impossible to go through the whole database. So okay, let's set an algorithm to do this. So what the algorithm is going to do is that find a group of customers or groups of customers that like the same, right? So you're finding maybe probably okay, customers that like a particular thing. They have similar attributes, they have similar things in common. For example, okay, this particular group, they all kind of like this brand, kind of buy, okay, probably this group, they like striped clothes, some like clothes with polka dots, then at the point bought this kind of, so yeah, something like that, which kind of grouping them based on probably interests. Okay, probably he sees that this set of people, they have interest in this particular thing, so they can now decide that okay, the kind of marketing we are giving these people, right, or the kind of product we recommend to these people is based on probably things similar to this, right? Things similar to okay, this brand of bag. That's what we kind of be putting so that the person want to buy it. Okay, right? So that's like it's a scenario where you are kind of segmenting customers. Another scenario is, for example, a finance company, right, that wants to know its customers, right? You want to know what services its customers would like. right? I think I worked on a project like that where we are trying to find kind of distinguish, okay, what customers in Nigeria, right? What are they interested in? Okay, what about customers in Kenya? Okay, what about customers in Ghana, right? What were they really interested in? And what I had to do as a data scientist is try to find features, right, that the products that the company is offering, that these customers actually interested in. So for example, people in Ghana, we noticed that okay, they're less interested in the banking aspect, and then they were more interested in using invoices and making life easier. And then Nigeria, what we found out was that okay, these Nigerian people, they just want to find a way to transfer money, from one place to another. Like whatever app is doing, does it allow me to transfer money? Yes. Does it cut charges? Does it remove is the charges less? Is it lesser than bank own? Yes. Then they'll start using it. Just like Kuda, free, you get to transfer for free and that kind of stuff. So you kind of like notice that kind of trend. But how did we find this out? Like have to like do clustering to see, okay, this region, okay, this is what they like, this kind of people. That's just like a case scenario. So doing it has actually a whole lot of applications, right? So what you're trying to do in essence is try to see what groups, right, you can form. Then you can now notice that okay, this kind of people, right, we can give them more ads related to making invoices, right? So be sending notifications to them based on, okay, remember to make invoice, you can use your invoice to this. Then this set of people that are actually more interested in making transactions, okay, you tell them that you can do this, give them give them notifications based on what they like. So that's like what you can do with clustering. So yeah, I hope you have like a better real life like a real life matching what clustering is and what it can be used for. Okay, so let's quickly walk through this data set, right? So checking a brief info, there are no missing columns, right? It has 530 rows, and then you have objects, you have integers, you have floats. So what we are most interested in basically is we want to see actually a couple of columns are categorical, right? But what we want to see is okay, artists, what are the top artists? For example, me, right? I want to see what the top artists are, right? Um what how danceable it is. If I'm somebody that I like to dance, I like music that I like to dance to. Probably some people like music that they like slow music. They like, is it, what do they call it? Is it blues? I can't even remember. Sorry. Okay, that's them. So do a quick descriptive analysis. You kind of see, okay, standard deviation, check the mean, check the minimum. You do this basically to kind of have like a brief overview to see the outliers by comparing the maximum, right, with probably the 75%, see the distance. So you can just give you like a high level overview of what your data set looks like, right? So me, I'm interested in, I want to see, right, the top, what are the top music, right? So top 5 music, yes. So, and then I'm seeing, is it genres, what they call it? I think so. Afro dancehall, Afro pop, missing. Okay, these ones are missing columns. Like a lot of music do not have names. Probably they are not grouped into genres. In fact, this is even a good use case in the sense that there is a list of music, but then it's not everything that was grouped into a particular genre, right? So what I can do is try to use this clustering algorithm to group this music into their own genres, right? So I'm trying to, okay, I know that some already are into Afro dance or Afro pop, but then I cannot just take a music and say, oh, because it looks like this and then group it into this. No, right? It has to have some similarities. Probably a particular music set it has this kind of danceability ratio. It has this acoustic ratio. It has like some other kind of ratio. So it's the machine learning that is going to figure out, right, how can I group these data sets, the ones that do not have a particular genre, right? How do I group them based on this particular stuff? So where it's not okay, yeah. So you have Nigerian pop, you have Azonto beats, yeah, right. So yeah, these are just like some visualizations. This is everything basically. You can see that some have very, very small amount of data. Right? So yeah, you can plot heat map to check the correlation between features. That is the length of the song, you're checking the popularity of the song, danceability, acousticness, the energy, the instrumentalness, right? Liveness, loudness, speechness, tempo, type signature, right? You can try to see if these features are correlated. Yeah, and these are some visualizations, but this is the part I'm mostly interested in. So now, after plotting a scatter plot between the popularity and the danceability, right? So you see that everything is, if I decide to group the whole data according to that's me, right? According to the popularity and the danceability, right? And then I'm grouping it according to the top artists generally. You can see that everything is scattered. Sort of remember that some of them are missing, right? So what clusters sort of can I form, right? What groups? How can I distinguishly group this data? You can see that everything is just scattered, like everywhere, right? So I can actually use clustering algorithm to properly group this data. So you see that all the greens are probably in one part, the blues are in one part, the is it brown? They're actually in another part. So this is how the data set looks like in the raw format. So now we're going to see how we use clustering algorithms to actually put this data in a proper format. Right. So let me go back to my slides. Yeah, sorry. Let me continue. Right. Okay. Okay. So before we do that, right, let me explain a couple of stuff. So what silhouette score is used for is that it's used to evaluate the quality of clusters created in terms of how well these clustered are. These samples are clustered with other samples. What do I say? Okay, basically, right? If you're calculating a silhouette score, it's ranging between -1 to 1. Now, if the score is 1, right, it means that the cluster is dense and is well separated from other clusters. Now, and a scenario where it was, okay, let me go back here. Now we can see that, okay, the silhouette score for this would be probably something towards 1, because you can see that the clusters are dense, that is, they are closely related to each other, right? Compared to, okay, you can see that they're actually closely related to each other, although there are some points that are far away, but you can say to some extent these clusters are dense. So you can see that the silhouette score is towards 1. So it's used to evaluate the quality of clusters. That is, you want to see, okay, how well are these clusters formed? Like how well does it make these clusters? Not like it's just making random stuff. So this is good because in clustering, yes, one thing I have to talk about is that you're the ones who actually determine the number of clusters that is formed. So that's probably one of the, would I say, downsides to it, because you're the one to determine, okay, but how well can you tell the number of groups that is perfect for that data that is left to you, right? So if you decide that, okay, can I find 2 groups that accurately explain this data, right? Does 2 groups explain it accurately? When you actually plot that particular cluster, then you can tell, okay, 2 groups doesn't seem to explain it more. Okay, what about 3 groups? What about 4 groups? So now silhouette score now calculates how well these groups you formed, right? How well do they capture the whole data? Okay, so there is also the elbow method. So now what the elbow method, as you can see that, okay, there's a particular line. Now that elbow, right, that elbow tells you the actually the optimal number of clusters. So now, the downside I talked about clustering was that you don't know exactly the amount of clusters that best fit. So now the elbow method, what it does is that it helps you find the optimum number of clusters based on your data. So now at that point where it tips, and then becomes straight, that point is what's called your elbow method. That point tells you the optimum number of clusters. So from here, I can see that it's 3. So it's telling me that for this particular data set, 3 groups, actually captures the whole data. Right. So variance is just the normal definition of variance. So how far are your data points from the mean? Right, if we go back to this image, right, you can see that some data points are extreme towards the far end, right? Some are very close, some are very far, right? So variance just calculates how far your data points are from the mean. So this, even with this, you can also estimate how well your clusters are formed. If the data point is too far, then probably you need to have another cluster for that set of data points. So rather than merging them all into 2, you can create an extra cluster that better describes those data points that are far, far, far away. So, okay, so yeah, let's find genres in a music data set. So, okay, where's my notebook? So now, yeah, let's continue. So first of all, right, I created just like a small data set for this. So this data set I know has two features, and then I'm now trying to, okay, let me make it have 3 features. Right. So for example, I'm trying to find, if I say, okay, yeah, this is the data set. Right. Okay. And now I want to try out k-means. Now for k-means, I have to explicitly state the number of clusters I want to use, right? So now I'm not using LB method, I'm not using any of that. So I'm just coming in raw, right? So I want to find the number of clusters I can actually form, the number of groups I can form from these features. Now, mind you, right, if you have like 50 features in your data set, doesn't mean that you're going to have 50 clusters. So like, do not kind of make that mistake. What you're trying to do is that you're trying to group your data into clusters that best describe it. Like trying to find the best groups for your data. So if you have probably a data set of 3 features, having a cluster of 2 or 3 is also not too bad, or 5. So okay, I'm assigning it cluster of 2, trying to fit predict with the training that I created. And now when I run this, okay, let me show you. Right. So okay. So let me print the result I get. So what k-means does is that it groups all these data points, right? It groups them into classes, and I assigns what they call cluster IDs. So now cluster IDs is actually very good because it's more like you are protecting the identity of your data. So in cases where you are dealing with sensitive data, like, okay, you're talking about race, you're talking about gender, or something that can be sensitive, it's good to kind of use IDs to represent them. So probably your model, probably you're dealing with a sensitive data, like something that has to do with race or something. Yeah. So because you're not explicitly stating that, okay, this race are ascribed to this, so you don't want to probably state it as that, or you don't want it to be seen like that, you can just assign a cluster ID. So now k-means has assigned that cluster ID, right? So let's see. So you can see that the whole data set has been formed into 0, 1, 0, 0, 0 and 1s and 0 and 1s and 0 and 1s. A lot of 0 and 1s, right? So yeah, it has taken my whole data set and then transformed it into this. So just to be sure, or just to keep in check, K-means clustering is probably not the same as would I say label encoding or something. I don't know, that just crossed my mind. So yeah, they are not the same at all. So it does a entire transformation to the whole data set and then reduce it to the whole data set, right? It used the whole data point to the classes. So now what I want to do is, let me plot my results, right? So I'm creating new code. So now I want to get the unique clusters. That is how many clusters were actually formed. Okay, yeah, 2 actually, because I explicitly stated 2 here, so it's going to be 2. Then okay, now what I want to do here is I want to get the index of each. For example, this 0, right? What position is it in my data, in my training data? And then I want to plot it. So I'm getting the index, or called the filtered label, and then I want to plot it, right? So this is what I get. So now K-means is telling me that it thinks this and this, right, they are one cluster, and this and this, like these two, are also like another cluster. Now K-means algorithm, right, it has its own downsides. It has places where it's useful. Now K-means does not scale well. It has the scalability issue. So that is why it's actually good to drive with other algorithms too. So yeah, K-means has that issue of scalability. So now, but looking at it, right, what I can see is this looks like a cluster to me, and then this looks like another cluster to me, right? But let's try with another algorithm and then check. Okay, so I'm using the DBSCN algorithm, right? Now the thing about these algorithms is that the parameters, okay, let me not call them I'll call them hyperparameters, because they are what actually determine how well your data, like how well your cluster works. So the kind of hyperparameter you tune, if you tune it well, you get the optimum results basically. And for DBSCN, you have EPS, and then you have minimum samples, which is the minimum sample that is at least. Now DBSCN is different from K-means. Now the difference is that what it tries to do is it tries to find the minimum number of, okay, like you are going to set that minimum number of clusters. So okay, you are saying, okay, probably for me, I think it should have a cluster minimum of two clusters. So for DBSCN, you can find more than 2. You can find 3, you can find 5, you can find as many, right? So it's it's very good for identifying outliers. So points that do not exactly fit into that context of, like, do not exactly fit into the 2 cluster, right? So DBSCN kind of points them out with you. It now groups them as their own clusters, standalone clusters. So that is the difference between DBSCN and K-means. So here EPS is like it's more like the distance between you're calculating the distance between each point in that cluster. So I'm giving it that for a particular data point to be in this cluster, it must have minimum distance of 0.2. So if once it's outside 0.2, right, I'm saying, okay, it's not part of the cluster again, right? So yeah, then I'm going to fit predict it. The unique number is 2 already, I know that, and then I want to plot it. Okay, so running that, yeah. So now I said DBSCN, right? What it tries to do. Initially, I stated 2 clusters, right? But you can see that it's giving me other clusters that it sees as outliers. So it's saying this cluster is an outlier, this one is an outlier, this one is an outlier, right? And then it's saying that, okay, I can see one major cluster, and then the others are like kind of separate outlier clusters on its own. So now we are still on the journey to find what algorithm best represents my data. So now here is Gaussian mixture. It's just like k-means. You specify the number of clusters or the number of components. Then you fit, you predict, and then plot. Now, Gaussian mixture is like an improvement of k-means, basically. So the downsides that k-means has, it builds upon it. So you can see that Gaussian mixture actually correctly, would I say correctly to some extent, right? Actually separates and then groups these data points into clusters that might make sense to me, right? So yeah, I think these are just some clusters you may want to try out, basically. Okay, then the last is agglomerative clustering. Okay, let me change this to. So this is what agglomerative clustering does. So it does not really describe it as much as Gaussian mixture. So I can say, okay, I want to go with Gaussian mixture. So now I've only shown you the different algorithms, right? And I've shown you how they sort of work. Right? So I want you to try this out with the Nigerian songs data set, which I'm going to give you the link. And then I want you to see how well these algorithms, right, how they perform on each of those clustering algorithms, right? I didn't use the Nigerian songs dataset here. Yes, I used my own training dataset, but then I already introduced the dataset here, right? A couple of visualizations. So now I want you to, as a challenge, right, try these algorithms with the Nigerian songs datasets and then compare the results. And you can also share that on the Discord channel, right? See, think, yeah, that is all from my side. So yeah, if you have questions, you can ask. Okay, I'm seeing a question in the chat. Will the cluster method work on all the features or specific features we specify? Okay, when you're it's more like you're taking your old data set. So you can decide to, if you want to use it on specific features, that's fine to you. If you want to use it on your data set, that is also fine to you, right? So whatever feature, it just depends on what you want to build or what you want to do. So you can decide to, if you use the old data set, right, you're trying to find classes that will best describe these data points. Yes, it's fine. It would work on it. And if you also want to specify the kind of features, yes, it will also work on it. Someone is raising up his hand. Yeah, I think you can speak.
Good evening. Thanks for the session. My question goes thus that the whole idea of clustering, I don't know how it's differentiated from classification method. So I think you will help us clarify that point. That's my first question. My second question is that what is the main outcome of clustering? Because what you just showed us here is something like graphs. So what's the main outcome? What's the main output of clustering? And could you please give us some real life examples of deployed model based on clustering? I think those are my questions.
Okay, thank you for your question. So for the first one, you said, how does clustering differentiate from classification? Okay, so for classification, you already have labels, right? So you already have a target that you want to predict. You already have, okay, for example, you want to know if a customer will buy a product or not. Probably you're saying, okay, no, let me say, if you want to detect if a transaction is fraudulent or not. So you have this transaction, this price, this date, this time, this platform, then your target is fraudulent. Then for the other one to, okay, fraudulent, not fraudulent, fraudulent. So you already have classes. So that's for classification. But for clustering, you do not have these classes. You just have like your data. And then what you want to do is try to find the best kind of group it, right, that best describes and represents this data. So that's what you want to do. So you want to find these classes, like you want the algorithm to find these classes, just like is an example of unsupervised, where you're not providing a particular label for the model to predict. You're just giving the model the whole data, and then you're asking it, give me predictions or give me classes from this data, right? So for your second question, a real life scenario. Okay, you said I gave graphs. Yeah, the graphs are just to show you the distance. So it literally like I think I showed it in my notebook, like a set of data points. So each data point has.
Sorry, Bumi. I don't know if I can come in here
Okay.
and maybe answer some of these questions. Am I permitted? Just now.
Yeah.
Okay, good. So the second question is, what are the main outputs? Is that the question you're about answering now? Can you answer me?
Yeah. Yes.
Okay, good. So from what Bumi was sharing or what we've done today, we see the different genre of music, and it has gone through the data sets to identify, to classify them, to cluster them rather, to categorize that, oh, these people share similar traits. And based on what we've done today, I think we have two categories. Am I right? So those two categories, what you do, you can save the results as additional column on your data set. The outcome in itself is not the immediate consumption. So when you save the additional column, what category do they belong to? You now do more we call it expository analysis. You know, for each of those categories, you look into it again. You've done this analysis before, but you have to do it again and segment them by that category to understand what is common to these people. You might not even know what to call them. You don't know what, and I'm going to cite an example here. But when you categorize them, you now look at what is common to these people. Why are they different from one another? And that is where you can now spot the bar chart for this category A compared to the bar chart of category B. You will see the traits. You can now name them. Oh, this category of people this is what is common to them. So this is a name I'm going to coin for them. This category of people, this is what is common. This is a name I'm going to coin for them. And in most instances, the results are not the output in itself. You need that result to feed in as input to another model. It makes the model more better, more powerful. And a use case of this is customer. I actually did this while I was still working in the insurance industry. Is customer segmentation model. Now let me play the scenario here. Every customer calls, and when they call, you just treat them, hello, can I know you? What's your name? And you collect information about them, and that is all. Some customers, we call them high network customers. They won't take it with you. When they call you and you say, hello, can you know what? You mean you don't know who I am? It's because we don't have much of this, and that's why you are not. That's an insult. But because you don't actually know, you don't know what's your name. Is that too hard, too much to ask for? But when you build a customer segmentation model, for example, you have all your customer details, how much of value, how long have they been with you, how much of the service have they subscribed to, or how much product have they bought, and you have all those information about them. And you run clustering algorithm like this, it could separate them into 4. And from those 4, it could be any category, by the way. And from those 4, you now analyze them to know better what is common to these people. And you'll be surprised that, some people are high-end because of the volume of transaction they've done with you, and because of, some maybe where they live and all those kind of traits. So now that you know that, these people are actually high-end customer, you rename them as high-end customers. For those that maybe they're middle region customers because of the way they transact, and some maybe they're just low retail customers. But that classification or that clustering will give you a category for each of those customers, and you now analyze it further by checking graph and chart what is the similar scenario here, and the moment you know what is common, you then rename them. In my own use case, then we had that category, we now put that solution into RFM. RFM means recency, frequency, and monetary value of the customer. And the final result was something that whenever someone calls and you tell us your policy number or your customer number, the customer service already have a dashboard at their front. Once they just put in that customer number, I just show them the details. This is the category this customer belongs to. If they say hello, the next thing they say is hello, sir. Because they've seen, this is an high-end customer. And the person feels, yes, you know he's talking, It helps you to personalize your engagement to customer. That is one solution. And you won't be able to personalize that call, that engagement, if you don't truly know what category the customer belongs to. And this clustering is one of those solutions that, let's just throw the data, let it discover the category. We will now analyze the category further to know what to call them and what is common for each category. I hope this sort of answers some of the questions.
Yeah, I think it did. Thank you. Your hand is still raised. Okay.
No, that answers my question. Thanks very much.
So someone asked, can clustering be used in grouping of programming activities in an IT company? Okay. Programming activities, it depends on what you want to achieve. But I think so. You want to find what kind of activities are you looking to achieve? And just like it said, it's not like the result of the clustering is your final result. It's just going to help you dig deep. But yes, if you want to find the kind of activities, I'm trying to relate with this though. But if you want to find, probably you just want to know, have an idea, okay, what kind of groups sort of can I group my IT company or something? I don't think I actually get the question well. Okay, I think the person is typing. So if you have any other question, please ask. Okay. So in the meantime, I'm going to share the link to the data set and also link to the slides and notebook and also the recording. Okay. Says activities like daily popularity chart of how your product or application is increasing or growing. I don't get the question. So you want to use clustering to determine the kind of activities in an IT company, and you're saying activities like daily popularity chart of how your product or application is increasing or growing. Okay, are you trying to find what IT, like what contributions each IT department is trying to is contributing to your product's popularity? Is that what you're trying to do? Oh, okay. Yes, something like that. Well, if you have the data for that, I suppose. So you're trying to find, I suppose, how each okay, you're trying to find how each IT company sort of contributes to a particular product, right? What activities, how their activities contribute to it. But I'll still like to know what outcome are you actually looking at? Because I'm still trying to like put the picture, but I'm not getting it. Or Mr. Olariwaj, do you understand what the person is asking?
I have similar thoughts with you. The question seems not so clear. But if I could interpret based on what I'm saying here, if what you are interested in activities like daily popularity chart of how your product or application is increasing or growing. You don't need classification or clustering for that. It is believed that you have the data, and your data shows the type of activities, your data shows the count of activities, and the data shows all those things. So it's just data analysis, just building your bar chart, your charts, and dimensioning them using the categorical variable that you have. But if you are interested in understanding a common theme, what is a theme of interest? These are just volume of data. You don't have the time. You cannot bring out the inherent, you call it latent relationship, something that exists within them, but you can't just see it yet. But you want to train a model to bring that in and then classify all these activities to what is common. If it is that, you can then throw all the activities data. Obviously, you must have the data that can give that. Then the clustering can regroup them, and so maybe these activities have common things in interest, but will not tell you what is common yet. But you always only categorize them. They have things in common. They have things in common. You then need to now analyze again to by diving deep to understand. Okay, well, if these guys are grouped to be the same thing, what then do they have in common? And you start looking into data. Once you find what they have in common, what name should I call them? What team should I call them? How should I tag them so that I can rename whatsoever value, be 1, 2, 3 or 0, 1, 2, 3, that's labeled to something that relates more to the business. Thank you.
Okay, I think does that answer your question?
For instance, to keep data of your product is going, of how your product is going, use clustering to group it during a meeting with your board per se. You don't need clustering to, if you want to group your products, they already have product categories. It's just dashboard analysis to group them. But it is when you're interested in teams, like I said, something that is common, but you don't know, but this guy can be broken down. What is common? Then the algorithm can look into that data and tell you, these guys, I'm going to group them, they're the same thing. Something is common to them. These guys, something is common to them. That is when you can do that. I'm not sure clustering is fit for the, is grouping. Grouping is correct, because that could be something you are hearing from this session today. Is grouping there? Can I group something? You can group, but based on the data you have, you don't need to do machine learning to group. If you have different product type, just plot a chart and put the product type there. It's going to automatically break them into the categories. Don't literally need any machine learning to do those grouping. Thank you.
Yeah, that is definitely correct, because you already, just like you're looking for what you already have. Some things you can use data analysis to do, like you find it. But in scenario where you just want to find, you do not have like something already, you just want to find, right? So that's when you use clustering. So if there are no more questions, right, I guess we've come to the end. So thank you everyone for participating. Right. I would share my slides. Yeah, everyone.
All right. Thank you, Bumi, for sharing out of your wealth of experience with me. I started learning data science after I left school, and I started practicing specifically in 2018. And I could imagine I only found the use case of clustering in 2020. And I could imagine the way we are breaking this thing down. I'm like, you're a student. Are you a student? That, to be honest, I was following through. And I was surprised that, the depth of understanding that you are sharing with us. I mean, truly, if you go out for a master's degree and are teaching clustering, they won't teach more than this. On that and how you've taught us about the concept, on that and how you've done the demonstration for us. That was incredible. And there's a lot to take away from here. Thank you, everyone, for joining. And please remember to follow through with the Cloud Skill Challenge. I'm going to drop the link in this chat as well. From there, you can also see more content that you need to learn and grow with. Also, the link that I've dropped here on the chat area, you will see the link to the onboarding guide. There you will see the curriculum. A lot of sessions you've missed, you will see the link to catch up back with them. And even this, when it's uploaded, you will only find it on that link. So it is the link here, you will find it. which I'm dropping here because it's to be uploaded. And this is how you can get it. The slide, we'll make sure that probably the link to the slide will also be added, to the platform where you are getting this. So on this session, you see link for recordings, link for slide. So be uploaded to OneDrive, and I can just see the link to download. So make sure you follow this site. That is where you get update on past sessions. And lastly, share your wins. If you do not share them, who will? So as you are doing this, as you are practicing and you replicated what Bumi has showed us today, go online, share what you've done, put your code on GitHub, write small documentation about it, do a screenshot. It might be as simple as just record your screen, your Jupyter notebook, just scroll down and show people, oh, these are the code I used to run in 10 seconds or 15 seconds. Then share that video. As simple as that, your potential employer or people who will end up helping your career or people who become valuable within your network will get connected. Don't joke with sharing your wins on social media. That is your new digital footprint. That is your social point. So share your win, use the hashtag NG30 days of learning. We will see it once you use the other hashtag. Then we'll be able to like and retweet, and then support you. Thank you everyone once again, and thanks, Bumi. It's time for us to call it a day and keep learning, keep growing. Bye, everyone.
Bye, everyone. Thank you so much.